If there are brigades you're interested in, starting yourself after this, we're definitely interested in that moving forward. So this is just the starting point of how we're working with the community going forward, and this is just a preview. And then also we're going to show the results. We're going to do some lightning talks of the hackathon teams that have been working over the last 2 days, and you have the power to award the winner. So we'll show you how to vote for that and a little bit as well. But with that, why don't we start with Luca and be talking about the first brigades.
Hello, good morning, good afternoon, good morning for me. So, yeah, thanks for the introduction. As David said, I'd like to talk a little bit more about the work that we've done in the deployment brigade recently. So let me first tell you what the brigade does. So the goal of the brigade is to create a shared, essential, reliable software stack on top of ONOS, easy to deploy and to maintain. The work we've done here comes out after the feedback that we got in 2 years of deployments of ONOS around the world from all the research networks. Guys of academia, research network, but also vendors. We count now 19 active developers and 33 people on the mailing list. Some of them are here. So, as I said, a minimal, easy to deploy and maintain a software stack, reliable to be used in production. For us, minimal means at least providing layer 2 and layer 3 functionalities to users, possibly on top of other packets, convergent packet optical network. Plus, of course, we are taking care also of the integration with widely used standards like MEF standards and NSI standards for the research networks. So, to give you a complete idea, I'd like to move immediately to the demo, then we can talk more in detail about the work that we've done so far in the last months and the future activities that we will do. Hopefully it will give you a better idea. Okay, so, in this example, we use Giant, a simplified version of the topology of Giant. It's a pure open flow topology, what we have in the demo. We assume that we are Giant, the operator. We have 2 labs, one in Bucharest and one in Madrid, that request essentially 2 feeds. First one is to exchange routes between them and with the rest of the world. So essentially, as Giant, we will provide to users layer 3 services. Second, the 2 labs want to conduct an experiment with CERN in Geneva, just an example, for which they need an on-demand layer 2 dedicated circuit. So the operator, Giant, will configure SDNIP for layer 3 services and VPLS for layer 2 services. Just in the interest of time, a couple of assumptions. The first one is that the routers and the endpoint IPs of the hosts that are connecting through the OpenFlow network, everything is already configured. And I will show you the interfaces configured for VPLS and SDNIP into ONOS, but they've been already configured as well. So what we will do is to activate the layer 2 circuit with the new applications created with VPLS. So, as I said, assume you have, can you guys hear me anyway? Yes. Okay. So assume you have the Giant topology, so basically different overflow switches. Specifically, you have 3 switches, the one at the top, that are in the hop where the different laboratories, in this case, should be the local research networks connect. Okay, open-flow switches. Each lab, it will be hopefully easy for you to distinguish them. It's distinguished by number 10, number 20, and number 30, both for VLANs and for IPs. Okay, so each labs will have connected to the same physical ports using one VLAN, a router, to do the BGP peering, and on another VLAN, the layer 3 host that needs to be connected in the circuit with the other layer 3 host in other countries. Okay. Same in Geneva, we have also a third host to connect in the broadcast layer 2 network, and also BGP speaker. which is what we use basically to receive the routes and let the two external routers talk together and exchange routes. Okay. So what will happen instead with VPLS? We will create a network as an example, and basically the three hosts will get connected together as they would be in the same layer 2 broadcast network, just with 3-4 commands. Okay, so this is the, again, simplified version of a general topology. Okay, as I said, let me zoom here. We have in each node, we have a layer 3 device that will be connected. Let's assume a computer. Okay, they are connected to the same port. Okay, using different VLANs. So, for example, this host here is on VLAN 110. Okay. So, say in Geneva, you have, for example, the BGP speaker and the additional host to be connected using different VLANs, same ports, different VLANs. Okay, so let me switch the screen. So, first of all, I can show you the interfaces. It's big enough, yeah. So I'm inside the ONOS instance, which is running, in this case, should be in Geneva. As you can see, I configure different interfaces already, some for the routing and some for as endpoint of the layer 2 circuit, each one for each city. As the NIP is already configured, is already running, the thing I can show you is that we receive routes from the external routers. Okay, so what I will do will be to ping from one router to the other, from Madrid to Budapest, in this case, and they ping, so they can communicate with each other. Second thing I will do, if you notice, in the third window here, instead the ping is not working. This is the layer 2 circuit. It's not working because we still didn't create any VPLS, which is what we will do now. So again, I will show you the interfaces, okay? So all we need to do with VPLS active is to say VPLS add, let's call it CERN, just because it's an experiment with CERN. And then we add to the network the interfaces. So we say add interface to CERN, interface, for example, Madrid. Then we add the interface Geneva. And then we add the interface Bucharest. We can see the VPLS just created. So we have a VPLS called CERN with 3 interfaces added to it. As you can see, in the first window, the network is already working. So imagine just the difference with the legacy world, where you create, in the case of VLAN, you go around, you need to configure access port, trunk ports, and so on. In this case, 3 commands, and things are configured. Of course, you can do the same through a programmatic interface, so through APIs, through CLI, through the UI in the future, it's coming. So something very simple, but that we think that can be reliable and can work in production. Okay, so coming back to the activity we are doing, now I can tell you a little bit more about what we did. So work already done from the brigade. SDNIP now can support VLAN tag interfaces and does automatically inter-VLAN routing, basically, and with VLAN translation. We have the new VPLS, which is the application you just see here. VPLS and SDNIP for the first time can work now together. We've done a new neighbor handler, which completely refactored what was called the X proxy arc, eliminating lots of code duplication and complexity. And of course, everything has all the complete documentation already available on the wiki. Work that we are doing, we are introducing encapsulation support into the intent framework and into the PLS to transport using another VLAN or an MPLS the traffic along the core. We are enabling meter support in the resource manager and the intent framework. So essentially, you will be able soon, hopefully, to track and enforce bandwidth. And we are trying to simplify in general the intent framework, the compilers, but also how intents are made today. Things that are in progress, not yet in there, but we are working on it. As I say, bandwidth tracking and enforcement, not just in the intent framework, but also in MPLS. Layer 2 and layer 3 working on top of packet optical, so on top of a converged packet optical network. So at this point, we will finally have layer 0, layer 2, and layer 3, all working together. And working on new specific devices drivers depending on the different deployments. Things still to do. Integration with the bandwidth on-demand app for the NSI support, which is something Giant is working on. Integration with Castor and SDX Layer 3, which are kind of similar to SDNIP, but there's still lots of code duplication, so we want to integrate the applications together. Integration with, it will come, hopefully soon, at some point, integration with NEF standards, so we will an already existing application inside our report called Carrier Internet. And as I say, the big picture, SDNIP, PLS, DoD over the packet optical network, plus new type of intents to simplify basically our life in the future. You're all very welcome to join at any time, the brigade. I left here some hopefully useful links for you. So you can go on the wiki, you can check our activity on Jira, and you can also write to the brigade using that mailing list. Thank you.
I'd like to invite the user interface brigade up next. Simon, welcome in.
Thank you, everybody. There's actually, we're one of the smaller brigades. There's myself working from ON.Lab. We have Stephen Burrows from the UK, although he lives half his life in Chicago. And we also have Vishwa. I don't know Vishwa, I guess there he is. So there's the three of us, basically. And we also have somebody who's interested, who's just committed his first code for review, and we're hoping that all works out, and so we'll have a fourth member. So we don't have a flashy presentation of what we're doing and where we're going and so on, but basically our charter is to incrementally improve the UI, the basic ONOS UI, and using the Jira backlog for prioritization and the order in which we do things. But over this release and also the next release, since it's such a huge task, what we're basically doing is writing a new version of the topology view. We're basically writing it from the ground up, because the classic topology view that you currently get essentially takes raw events from the server and computes what it needs to be shown in JavaScript on the client. And because of this new region model where you can break things up hierarchically, it was just infeasible to try and do all that computation in the browser. So the re-engineering that we're doing is essentially to compute what the UI should display down on the server side, so we're modeling that. And then as you navigate through from region to region, just the data that needs to be rendered is sent up to the browser. So what we have to display for you today is just the beginnings of the region navigation, and to show you that hierarchical view. So I'll hand over to Stephen, and we'll just make this nice, short and sweet, and then we can move on.
Hello. Yeah, so the JavaScript side, we kind of really simplified it in this release as well. So it's more object oriented. So everything you see in a topology is now a model, and you can extend the model and add functionality on top of that. So we've got a really simple topology here with two subregions in your view. So if we go down into London, we will zoom into London and we can see that we've now got two switches, each have a host, and then we have another subregion. So we can then go down into the Thames and then see this region as well. So the idea behind this is that we can have a continental view in the future, so you can start showing all the continents of the world. So you can have a topology within the US and then Europe. You can then zoom down in your pan, further down and scale into each regional view. You can navigate back out of this with a breadcrumbs at the top, if you can see that. And yeah, you can jump between the regions.
All right, thank you. Just show the dynamic scaling icons scaling.
Oh,
Okay. And so as you zoom out, the icons are now limited to a fixed size, so they'll never get smaller than that anymore. And as you zoom in, they will never get bigger. And that's it. Thank you.
Ali, would you like to talk about virtualization next?
That's
Great. Thank you.
Okay. So this is a virtualization brigade. It's also named the V Brigade for cool people. So the brigade is made up of a bunch of people a couple people from Siena, a few people from SKT, Sangam was here. Immediately had a chance to meet Daniel and Sangho, which were here, but they had to leave a bit earlier. I'm the brigade leader, but I'm the leader in the sense that I don't do very much, and let other people do the work. And I just make sure that they behave. And other than that, Sangin offered graciously to give this presentation after me whining and saying that. Thank you.
I'd like to introduce our scope. And we don't have a demo not yet because we discussing and considering API interface and structure. So I would like to introduce the scope. We actually defined the virtualization API like add controller, add switch, these things, and implement. We focusing. Our first proposal is 14 OVX based feature to ONOS. And there are three virtualization functions. First is topology virtualization, and address virtualization, and control function virtualization. These things is our short-term focus. We focus in this year. So in future work, we will provide three things and more. First, the virtual network pausing and restarting. This is like a VMware or virtual box. We starting VMware like we provide instead of VM. We will provide a virtual network like VM, and we will provide a virtual network snapshot. And this is the pausing and saving that feature of virtual network and reviver and next time or whatever. And intent based, we provide intent-based virtual network in future. So we call these three things long-term focus. And these things is already, some people have already heard about yesterday. So actually, our network virtual, I explain the purpose of network virtualization. And tenants, some people and tenants specify their virtual network and their virtual network attributes. And virtual networks are fully programmable, and tenants can deploy SDN in their virtual network, and they also can use their SDN controller or ONOS, and enable multiple tenants cloud on the shared physical infrastructure. So this is our architecture and our purpose. Basis is a physical layer, and ONOS as a network hypervisor that ONOS is virtualizing network resource or these things, and upper layer is network OS like ONOS, ODL, like this network operating system. So we don't have demo, so thank you. This is my end of my presentation. If you have any question or interest, please contact the virtual brigade mailing list or wiki site. Thank you.
And lastly, I'll invite Patrick from the Dynamic Configuration Brigade to speak to you as well. So welcome, Patrick. Oops, sorry.
Yes, hello everyone. Today I get this opportunity to show what we're going to do in this dynamic configuration. So in simple, is bringing the NetConf capabilities for the ONOS. Right? So the team first. Here is the members so far we have. Thank you, Dave, to bring a lot of effort in the last months to give us a great opportunity and let us to build these things. To the city of Digimos, and now we have the development team from the vendors and Digimos, Fujitsu's, Huawei's, ON.Lab, and the QA teams from the variety. Here is information for the teams. Basically, the goal is enable the network operators to bring up and configure the device from the different vendors and verify the configurations. That is the goals. Okay. The benefit, the benefit is in summaries over here from the operators and vendors point of view. I think a lot of people know about that. We can skip this one to see what the components involved. Dynamic configurations here is from the user's point of view. Okay, when they start try to configure the device, some things you need to build into your controllers. So now here is big pictures. Like in the UI side, so you have a device config and UIs. Now you have applications which is running in your controllers. You need to do the source to provide data per configuration data per system. So and underneath we have to have the net of drivers. So in the device side is the Windows device. Okay. So here is the sub of the combinations. So you see the one application you can see is the one service. Okay. So the device side is from the different vendors. Okay. The combinations is one application, single service can program a multiple vendors device, or the program a single vendors device. It's a combinations, or the multiple service can work with single vendors or the multiple vendors device. So here is something we have to build is YAN growth chains. So we start this YAN growth chains work is back to several it's about two releases ago. Now the tools is almost ready. It's I think it's 99% features is ready. Some of us is already use this one to try to program the device like OLT device and the OpenLoad device. So they already use that ones. And I know the other guys use these ones for the Windows switch and the routers. So the YAN tools is almost there. Like I said, is basically the demo we planned here is demo one is a single Windows device. Okay, so we focus on just use a simple applications to configure the single Windows device. So the demo tool is basically is a single service on a single Windows device. So here is the combinations I said before. Over here is a demo 3 is a single device with a single service on a multiple Windows device. Basically, potentially you see when the orchestrators talk to the controllers, they basically want to provision the service as a whole is end to end, right? So we need to support this. So the example here is we're trying to use layer 3 VPN as a service to run these demos. Okay, so the number 3 plus, I don't see the demo 4 is basically some enhancement for the demo 3. The demo 3 could be you can build the one drivers for each vendor device. So, or you can build the common drivers, just inject or load the device models to manage and configure the multi-vendors device. So we're focused on the demo 3 and the 3 plus later. Here is some things so basically we spend the half days over here on the Wednesday afternoon when the teams come over here. We have a long talk, and we are thinking. So some things it is still a draft. We still need to figure out if they can meet all these four demos and the potential demo. So we're still working on, but now take a look at this. We take all the component and the related component from Northbound over here down to the store and to the southbound. So and also how the applications into the potentially provide RPCs through this running time stuff. So here is some things we put together. We still need working on this one to finalize this. Now it's a very good shape. Thanks Thomas and to put all these pictures here. Roadmap. So the phase 1, we're thinking the phase 1 is target the ONOS year 2017. That is April timeframe. We focus on the demo 1 and 2. Okay, it's a single vendor, single service. Okay. So I think it's we're covered in the release I currently right now, and the JMK. It's two more release. The phase 2, we are going to work on the demo 3, it's the multi-vendors, and with end-to-end use layer 3 VPN as a service to provision service and configure the service end-to-end on the multi-vendor device. So the futures after the phase 2, we are going to work on the demo 3 class, that is a common driver on the Southbound. Here is the roadmap where we're thinking. If you, Brian, if you have any comments or something, you can see the. Do you have any comments? No. Okay. So yeah, here's all I have. Okay. So we don't have to still. Okay. Now we got the tools ready. The YAM tools are ready. We have a lot of code. So basically, it's spread in the northbound and southbound, and even the running time code. So now it's a time the team put all the things together. We revisit the architectures and all the things. Today we don't have the demo for these ones, so we hope we can have something soon. Thank you.
Thank you, Patrick, and thank you to everybody who is either leading or a part of the brigade. And if you've seen anything that a brigade has talked about that you're interested in, you're always welcome to join. These are just getting started, and you know, as an open source project, you're welcome to jump in on all of these. So feel free to grab one of the brigade leads if there's something you're interested in from what they were saying. And also, again, we'll be spinning up New Brigade soon. So if you have an idea for a project that you want to build community around, reach out to me, and also be on the lookout on the mailing list in the blog. We'll have a public call for brigade ideas probably in a few weeks from now. With that, let's transition somewhat. So we showcased what's going on with the brigades. We'd also like to give some space to showcase what the hackathon teams have been doing over the last couple of days. So we're going to do lightning talks from each of the teams, and then William will get up and tell you how you can vote to pick a winner. And we have a grand prize to give to the hackathon team that gets the most votes. So with that, Ali, would you like to introduce the hackathon teams? Thank you.
Cool. So, as you all know, we had a hackathon during ONOS Build. We had 6 fantastic teams with great names. I'll just go through and list them. We had the Snappy, which is to build an ONOS snap for Ubuntu Core for ONOS. So that's kind of cool. You can just install ONOS as a snap in a completely confined environment. It's very cool. We have a Yang team that's building tools for integrated and debug. Adapting a link and device subsystem interface to with Yang, all kinds of great stuff. And we had a team called PCE for PCE calendaring extensions that are needed for path computation elements. And we had a cool team called Love Cording, which is a network monitor feature to calculate the latency between 2 switches. Followed by Roll the Control, which is an implementation of intent domains in ONOS. And finally, the list SDI, which as its name indicates is a list southbound for ONOS. So all of you here will be voting for the best hackathon team, and the hackathon winners will win The first prize is $1,500, second prize is $500, and finally, the third prize is a customized ONOS t-shirt. So it's kind of important that you pay attention to the presentations because you just don't want anyone to win the best. Right? So with that, I'll invite Schnappy to come and give their first presentation for the hackathon. No. Oh no, that's awful. Actually, I need your laptop so I can get them on display. Yes. Right. Hey everyone, I'm working here. I work on Ubuntu, and until last week I didn't know anything about ONOS, so it was great to discover about ONOS this week. We closed this project was to create an ONOS snap, and I work on this project with Vishwa.
Yeah, so my name is Vishwanath. I work in Verizon as an architect. I'm from India.
So what were we trying to solve? So when you're trying to use ONOS, there are people binaries, but for a new starter, trying to build ONOS or trying to run it and install it, it can be a bit daunting. I watched the ONOS builds channel, and people were having like build issues from time to time. And I mean, I think it's a common problem that people have a hard time starting with new software. So the goal of this project is to make it super easy for people to consume ONOS, to get ONOS, to play with it, and then to decide whether to run in production, and then to run it in production. So that's the first thing we wanted to solve, is making it easy to install. Snappy are a new, like Snaps are a new format, new application format, which is available for Ubuntu 16.04, Ubuntu 16.10, for Debian, Fedora, Gentoo, SUSE, and soon Ubuntu 14.04. So it's like widely available, and that was a way to solve that distribution problem. The second thing we want to solve is ONOS is this software listening on the network, and potentially you could send it like bad data, whatever, make it crash or make it like take control of it. So I have no idea what kind of like effort goes into securing ONOS, but generally speaking, because it's a network-facing service, we wanted to make it more robust to attacks. So we wanted to sandbox it so that it can only be what it's supposed to do. So that's why we started work on an ONOS snap, and we tried to make snap of it so that we can distribute it more easily and make it more secure. So with that, we present the snap work.
Yeah, so creating Snap is pretty easy because I learned Snap myself in just these 2 days. Of course, I have the creator of Snap with me. So all you need is just 2 files. So one is snapcraft.yaml. So YAML file is just application about this file. So basically, you just need telling Snapcraft that this is how I want to build. So I mean, this is nothing but a metadata of the package. So it has name, description, and apps. So whatever shell script we have a wrapper over here. That's for the form cluster and plugins. So inside service there is a plug data where we have network and network bind. So this is analogous to what we give for an app, right? So assume that we download an app from an app store, we actually give this app can have access to camera, this app can have access to network. So say we can specify the snap that this particular snap is contained for this particular permissions. So right now we just given permission for the network and network bind. And also we can tell that for now to run this particular snap, it needs some different dependencies. So we have JRE and other stuff here. So that is for the snapcraft.yaml file. And now that we just actually want, when it is in some snap, we just want it to download the source, build using bug, and get the output from target region and then install it and run it. So we just added a bug plugin. It's nothing but it just have 2 commands like run the bug, then get the target region, unpack it, and then give it for installation. So extending the plugin for Snap is pretty good because all it needs to just have some few lines of Python script.
So that's all we had to do to get a snap building. So we also got some help on debugging like those kind of issues. It's very small. I can do a live demo if I get a chance to fix like mirroring of the screens. But basically, what you see here is you just need to type on an Ubuntu system, whether it's like a server system or desktop system or 1604, 1610, and soon it will be like 44. You just like snap install ONOS. Snap is installed like out of the box on Ubuntu. So if you start like a new 1604 Ubuntu VM in the cloud right now, you can do snap install ONOS right now, and you'll get like ONOS installed. And then you can run the ONOS command, and you'll get like the ONOS prompt. Also got the web UI working, so you just log on port 8181. It's actually live in the cloud right now. Like if you want to connect to my server, you can connect to URL. You can see the live demo is up. So you connect with ONOS and ROX as a login password, and you can start playing with creating fake architectures. So that's it for, I'll try doing a live demo in a second, but I wanted to recap what we output. So first thing is, we have an ONOS snap right now in the Ubuntu store. So anyone can snap install ONOS and get it running on Fedora, Debian. I won't list them all again, but basically it's really easy now to get ONOS. This is 171, I took like stable version, but you can easily set up a CI or output it directly from the ONOS CI, so that it's published automatically. We have a GitHub repo for the Snapcraft YAML. Just either leave a separate repo, or you can decide to merge it with the main ONOS repo. So we could continue just to work between us, or get contributions from anyone. And you can find like the small shell script wrappers that we use for startup, Snapcraft YAML, and the plugin that Vishwas did. So if you want more information on Snap, go to Snapcraft.io, and you can find all the reference documentation on creating your own Snap for the project, or if you want to build different branches of ONOS, or if you're trying to create a new feature and you want to build it quickly and create it as a Snap, you can snap install your Snap and then remove it, and it's entirely done. It won't be anything. And that's it. So please come and ask us questions, and we were Team Snappy, and you can contact us on Slack, or you can grab us after this presentation. And if I still have 1 second. Oh yes, please vote for us, of course. I'll try fixing the yes. Okay, maybe that will work. Yes. So I like this regular ONOS shell, and if I go here on my again. All right, so this is like an actual like demo of the architecture. So it's the actual real Snap working. You're all familiar with ONOS, but I just want to show that it's like a real demo. We only started working on it yesterday. We were working like basically yesterday evening. It wasn't fully working. It was today, and it's all the ONOS features. Like we did basic tests of the no plugin and making create architectures, and it's all traditional ONOS. I think you're all familiar with ONOS, so basically ONOS is working, and so it's not a fake demo with that screenshot. All right, any questions? Okay. You can grab a second.
Yeah. The young team.
first thing is
You have to
we as part of this hackathon, we wanted to do two things. One is we wanted applications to start using Yang because Yang is new in ONOS. So we wanted to adapt Yang to the current device and links and show like how we can model Yang for any application and have it what you say configured or managed through Yang. So for this, what we did was we took a simple YAML file and then we modeled device and link through YAML, and we fetch these informations from the current device service and the link service. Okay. So for example, to get the device information, we have to support for any application, it will support to get the topology information. So how we get that? We just get the information from where the store is. So currently it is there with the device service. So we get the information from the device service, then construct it into the Yang generated Java objects, and then give it back. So with that, applications can support any UI. On day one, they can right now they can support restaurant on your phone. Tomorrow, once ONOS supports any UI, new UI like SNMP or CLI, which is Yang model, then there's no bug required for the application. So there is no sample application for this. So we want to put this up with the wiki, so it will be a reference where applications can see and start adapting Yang. So this was the first work. Then we had another work was right now with ONOS build migrating from the Maven to the Buck. The Buck plugin for Yang was having issues. It was not having the linker capabilities. It was not having the capability of integer issues. So all the code base that was there was only compliant for the Maven. So we had to make sure that the code base of the Yang tools is not tool dependent. So we made the code base of Yang tools into, we split the code base of the Maven, which was currently in Maven, and then we push it into a common tool. This can run any JVM, and then it will have a callable plugin. So on any JVM, the tool can be called. The caller can be a Buck or a Maven, and then they have to give what is the locations where the Yang files are there, what are the locations you want us to generate the metadata file, what are the locations that you want to generate the Java files, and that's it. So anyone can use this. It is not tightly coupled to either ONOS, or it is not tightly coupled to Maven or Buck. It is just on any JVM. So now for this, we had to make sure that the current code which is written hard-coded for any of the plugin related to find where is the repository, how to get the information. We stripped it down. We have made it as all as callbacks, and using those callbacks, the tool would just invoke it, and it would get information on where the environment it is running in. So currently, what we have done is we have ensured that the current code of Maven
fits into this architecture. So previously, our tool was tightly coupled to Maven, and then now we have started using it based on this tool. So with this tool, we have ensured that it can use the Maven callbacks and generate it, and still the generated jars have no differences. It's just the compile timestamp changes. So the tool works. It's just now the tool will be adapted to bug, and then you can use it anywhere you want. So this is the second job that we did. So that's it.
See?
TPC.
Hello everyone. Today for the hackathon problem, before starting, my name is Satish. I'm from Goa, India. So the hackathon problem we took is PC calendar. Okay. So this is basically scheduling the LSP pods. Scheduling LSP pods. One of the use cases what we got for this is currently like in case of data center interconnect, right? It's like which the WAN network is being controlled by controller where we use PC to set up the pods between the data centers. Okay. So in this case, there are scenarios like where we want to schedule the like where we have some kind of backup periodically, like sometimes the data backup happens weekly, monthly, or sometimes daily basis. Okay. So one way is like from externally you trigger setup frequently like using some external app. Okay. So another way what we thought is like we use the existing standards. Like we have a standard for of PC where you can pass on the schedule informations which and also the frequency on which you want to schedule and count on pods in the MPLS network. So basically here we as part of this hackathon.
To right, slideshow. Yes.
So as part of this, so this we could have done in two ways. Like one is in the app side, we could have started a scheduler and schedule it. Okay, there is one way where apps can be changed to schedule it, and the other way is like since our devices already support the scheduling part, like since also the protocol is also supporting to extend this information to pass on this scheduled time information. So we thought we'll extend the existing southbound protocol, which we have the basic protocol, and we have added the new clearly so that to pass on this information to the devices. Okay. So once this being set up, so once this client triggers, like the ingress automatically schedules the path for this LSP. Okay. So as part of this, we have extended the protocol, and also we added a REST interface and for the external apps to set up the path of the scheduled information, and we use basically local CLS for testing. and the testing is not completely over. Like we are partially testing it with our devices, with Huawei devices, and once this complete testing is done, maybe like we'll be planning to commit this coding data. That's it.
Love coding.
Is that your Twitter?
Yes.
Hello everybody, we are Love Coding and I'm Zhen Haochen, and let me presentation for you. This is our article network monitoring, and we want to test a big latency, and because we will present I will talk about our more motivation and feature and methodology and some issues and some troubles and Q&A. Yeah. And now I'm talking about our motivation. Why we should test the big latency? Because some network operator needs, because he wants to know the current network the utilization, and latency may be an important index. And in useful information, it could be a useful information because we get the latency, we could do the load balancing and some DDoS detection and QoS and another extending features. So we want to make this feature in ONOS. And let's talk about our feature. And when we apply again, I always later. Okay. And I want where is the bottleneck in our network, and I want to see the latency, maybe which link or which path. And how we could calculate this latency. So let me talk about it. In the past, we have done this feature on OpenDaylight, and our methodology is we send a packet out to the switch and break the timestamp, and the packet out will forward to the next switch, and this switch will table this and send the packet out event to our controller. And we break the timestamp. It's very simple. So we break the timestamp and we calculate the latency. But there is some issue in this methodology. It just calculate adjacent to switch only, because we only send the we only send the packet out and no any for modify, so you just forward one switch and use a packing message. So we just calculate the adjacent to switch only. And another issue is out of band connection, and it only switch the limitation is out of band connection, because if you use the in-band connection, you have too many latency in this RTT, this packet out RTT. So it maybe so you know the yeah, and then how sorry and someone discuss about this issue. So why we don't choose any two switch about the latency. So we think about if we migrate these features on ONOS, we can change it. And we think a while, and someone told, hey, you can use the intern. Intern, you can use the intern. So maybe a good suggestion. So how we use the intern to do this feature? Yeah. And in this scenario, we want to test these two switches latency. And then we use add point-to-point intern. and create a link, and then we send out the packet out, and then you will forwarding through this test and to this switch and go up packet in. The same workflow. So we regular timestamp and also calculate these two switch latency. So, and I think this endpoint to point internet, it helped me a lot. It automatically create this test. So it's very convenient. So it's when we did this feature on OpenAI is very hard because we have to write the application and send the flow, and make up this test. So I think that this internet is very convenient. And when we in this hackathon we face some troubles because the first trouble is how if we use this endpoint to point internet and we don't interfere with the current traffic because we set a flow modifier, it will interfere the current traffic. And if we do this test, we don't have we don't we don't bother the current traffic, you know, and the out-of-band limitation is not solved. Yeah, and we don't have the time to come out a network algorithm, and the time is the important product. Yeah, we don't have that. So sorry, we have no demonstration. Yeah, and thank you. If you have any suggestion, you can talk us, and we can make it better. Yeah, and we will better in next episode. Thank you.
Roll the control. Team, roll the control. Go on, roll the control. Roll on the control.
Hello, my name is Andreas Opazulis, and I'm from Germany. We are the role of control team. I am Michele from Keynote, Andreas from Germany, Francesco, and Thomas from ON.Lab. So, I will discuss briefly about our motivation
Actually, all of us, we are working in different projects, but we face more or less the same problem, which was that the current implementation of intent framework basically produces flow rules and flow objectives and assumes that there is individual communication with the devices. But we wanted to extend this in order to apply policies to external domains. I mean about I'm talking about domains that ONOS does not have direct control over the devices. So in our cases, we had some different technological domains, like domains that are controlled by subcontrollers, which are actually management systems for optical devices. And this was controllers that were provided by ADVA and Infinera optical providers. And also the case of ICONA project, where we have separate administrative domains to control. So we wanted to extend the intent framework in order to apply policies, express policies at the southbound to separate to remote domains and leave the domains themselves to apply the policies in the way that they can manage it.
Okay, so let's move for the architecture. I will briefly cover our architecture. So when you submit a connectivity intent, for example, an ONOS intent or point-to-point intent, this will be compiled into a path intent. But this path intent is again recompiled into something that we call installable intents, that are the flow intent, the flow objective intent, and so we add the so-called domain intent. So this is a high-level abstraction of what we can install in the network. So it's a policy-oriented installation inside the network, not anymore per device, but for the entire domain. This is the architecture that we try to extend. We have some problem where the demo is not running because we have some problem in the intent manager. We were not able to submit the intents at the driver level. The driver works, the intent domain works. We were not able to debug the problem for time for the time at the level of the intent manager. But so the idea is that we receive the not-bounded application submit an intent that will be managed by, of course, the intent manager. It will be compiled into, as I told you, installable intents, and the intent installer will take care of installing these intents through the flow rule manager or to the flow objective manager, or finally with what we add, that is the intent domain manager. The intent domain manager can be plugged with multiple drivers. We have an implementation for the ADVA controller, and right now what we are able to do is that we submit an intent, and this is split into flow rule manager, into installable flow rules for the IP and all open flow devices. And instead, we are able to create and generate an intent domain intent that is not being installed by the manager. This is what we have achieved, and we hope in the next days to fix up this stuff and be able to have something working. That's all.
Finally, list SBI.
So I will, go on to, and you want to ping to the 1.1.2. In that case, it will go through the router, this router, and it can be encapsulated. And after that, it will use the router's IP address to route to the destination router, and then finally it will reach the destination. So what does this map server and map resolver do? It tries to manage all the mapping information between the host IP and the router's IP. It's a standard protocol, and it is a simple way to visualize. So assuming that the IPv6, like the host wants to send one packet to destination, then the packet will be arrived in the router. The router will encapsulate that based on the mapping information that it has, and then after that, it just uses its own like routing, the routing locator to route it to the destination, and after that, it will encapsulate it in the destination router and then send to the host. This is a basic operation. So we have a control plane. So what does control plane do is it manage all the mapping information of this EID and routing locator. So how we can manage it? Basically, the router ETR is equal to terminal router. It will send the net register message to the map server. The map server will reply as a net notify. And if there is some like ITR ingress terminal router wants to route some sort of packets, and will ask for the map information from the net resolver. The net resolver will acknowledge with the map reply. This is the basic operation. So we implement that on top of ONOS, and there was some basic as already been supported, some primitives and those types of things have been added. But what we did in the hackathon is we achieved three things. So we added a new list canonical address format, which is called traffic engineering. So this address is specifically for doing this traffic engineering purpose. And then we also added the map server and the map resolver. Previously, there was no such a thing for this stuff running on ONOS. So map server typically is a receive map register and store map information along with path information, since it's traffic engineering, and also acknowledge with the map notify. Map resolver is receive map request and look up the map information that it has and acknowledge with the map reply. And finally, we integrated the list data plane, which is open source, it's open source as well. It's we call open list, and then we integrate that with the list control plane, which is ONOS in this case. And they show them like that. Oh, sorry. So we added the traffic engineering LCAP, and we had one issue when we implemented one. Oh, sorry. So if you can see the old one, so in a IETF draft, the old one has such a message format, which has been implemented in the open list. But in ONOS, we use a new version of the traffic engineering LCAP. So we try to come up with we find the differences, and we try to fix it both in the open list and in ONOS. So finally, we got it work. So this is basic operation. So once the open list sends the map register, then we use Netty to manage a whole bunch of UDP connections between the open list and the ONOS. And the ONOS will take inside ONOS we have a map server, so it will take care of all the map register message and notify. And for the ETR, we also map resolver is receive the map request and we reply to map reply. Yeah, so this is basic operation. So we implement the whole stuff during the hackathon. So it was a lot of work, and in order to show the demo, we make this type of a scenario. So assume that there is a host want to communicate with the destination like this, and at initial point, actually ITR has no mapping information between the destination ETR and this IP address. Then how it can find? First of all, ETR will make a map register message, and it has it provides two paths. One is from ITR and the RTR1 and to the ETR. Another path is from RTR to RTR2 and the ETR. So these are two paths, and the ONOS will acknowledge it by using map notify and store two paths actually. And if there's one packet from the host to the destination, it will arrive here. And since it has no routing information, it will ask ONOS how it can route. Then ONOS will tell that it has two paths, and the ONOS will randomly select one path, and tell that management reply. And then this packet will be sent to the RTR1, because in this path you can see that it's ITR, RTR1, ETR. So the ITR knows the next half of the path. The RTR also has no information, so also it makes some requests to ONOS and reply. And then finally we will receive the ETR, and it's been done. So I will show some demos about that. So in ONOS, I checked out the latest version of ONOS, and this is sorry. So this is ONOS is running, and I activated this provider already. So now what you can see is like, what you can see is here, yeah, you can see that is activated. So in the data plane, you can see that I can pull the log, and you can see that it's sending the net register message, and it get acknowledged by ONOS. So it's received packet something. And for traffic engineering stuff, if you can take a look at the slides, we're gonna ping from 10.1.1.2 to 10.2.2. It's in different subnet, and this is the machine what you have to ping. So this is the IP address of this machine is 10.1.1.1, and I try to ping to the destination. So once you ping, then it will show you that it will, just automatically set all the passes and receive and so on. So sit in the middle, and they can manage a bunch of packets and so on. So this part has been done. So I think it requires some sort of code review, and that can be merged to the next step. So I think now we kind of support release officially in ONOS. So thanks for your attention. Any question?
All right, so now has come time to vote. All right, so to vote, you need to follow those instructions.
Who's doing that in this today?
Yeah, I think.
Apologies for this. We'll be right with you, but this will vote. And then while people are voting, we'll say a few closing remarks, and then after that, we will award the winners. So, apologies. I don't know if my laptop's just not happy. Should I feed you something? All right. What picture from today?
So while we do this, make sure you're connected to the internet. Start connecting your phones or your devices.
So this is something.
Yeah, so this is how you vote. Pretty straightforward. The voting will end after Bill's talk. Okay, so you have. How long is Bill's talk? How long is your talk? 10 minutes. You have 10 minutes.
You're unable to find. Can everyone see the URL? Okay, are you connected? Are you voting? Is it working? Yes. Okay.
Did everybody come to the URL?
I'm trying. Can you go back?
Yes. No, actually,
Actually, it's tinyurl.com.
tinyurl.com/ONOS.
is everybody set with the URL? Okay. Okay, hi, I'm Bill Snow. I'm responsible for engineering operations at ON.Lab. Do we have any students left? Yes? One? How about others? Any other students?
Students.
You don't count. All right, well, at least we have one. Thanks, you're awesome. Really special guest. Appreciate you being here. Oh, Carmelo, yeah. Okay, well, another guest. Okay, anyways. I'm really happy that we have some guests, especially with the PMC. Okay. Thank you again, UPMC and York 6, and to our other sponsors. Okay, first a quick story. When we started ON.Lab, and we went to our first real building, we had to get internet service. And I called my favorite provider, because ahead of time, I had found out that there was a fiber running into our building. So I was very happy. I knew we'd be able to get good internet connectivity. As a very large provider, had a fiber that they owned through the network. So I called them. They could not get that fiber provisioned. They owned the fiber, but they couldn't provision it. They told me they could provision it in 6 months. This is in February of 2013. We were first demo of ONOS coming in April. And we're trying like mad to get ONOS ready for that demonstration. And now we're moving into a building which is pretty disruptive to begin with. And now we have no internet service. Because they want to set me up first with DSL for 2 months, and then they want to send me a fractional T1. And then they hope that by the end of the 6 months, they'll be able to provision a 10 megabits fiber. Okay, this is madness, but this is how it is. That confirmed to me that I was in the right job. Because I wanted to fix that. And by the way, what we did is we went out and we bought 2 Verizon modems. And we lived off 2 Verizon modems for a month. And we never got our large provider working for us. So we actually ended up going to a wholesaler that wrote on top of them. Okay, so how do you really transform a network? You may remember the advertising that Apple did. Think different. Does anyone know who this is? Bill Gates.
Do you need glasses? Who said it? Ah, very good. Very nice. Nice. Yeah. So this is Pablo Picasso. Thought that would be somewhat relevant, but I also love his expression. Okay, think different. Okay, another very famous person said, focusing is about saying no. Does anyone know who said that? Okay, Steve Jobs. Great admiration for him. So this is very important to me and to the philosophy that we have, I think. It's about saying no. And I want you to think about that, because we get used to doing a lot of things kind of naturally, right? And we've been building up things in networking now for 40 years. So, love it or hate it, MacBook kept changing, right? And at one point they got rid of their CD-ROM drive, DVD-ROM drive, which drove me nuts at the time, but I think it's amazing that they have the strength and willingness to do that. Same, they only have an iPhone 7. Throw out your earphones, right? Because they're getting rid of the port. You may hear from a lot of the people in networking that, well, SDN isn't there because we have to have 5 nines from day one. Right? 5 nines means the availability, you're down for what, 4 minutes a year, right? Or less. And not only that, we have to have all the features that we've always had. And not only that, the security has to be better, right? No, that's not going to happen. So I ask you, do you think that Google, Facebook, Microsoft, Amazon think this way about putting new technology in the network? Do they think that way about networking? Absolutely not. Right? If they did, they would never get it deployed. Right? There's no way you can build up 40 years, take a new technology, and have all the same features and capabilities. We have a really unique opportunity right now to throw out a lot of stuff. Right? Let's throw it out. There's a lot of stuff we don't need. So I'd encourage you to reject complexity. And we've seen some complex slides here today, and I have to bite my lip, right, when I see some of them, because I think our job should be to work hard to make less turn into more. Right? This is a once in my lifetime opportunity to take a new look at networking and make it much better. So I believe you are what you do. I encourage you to find a mission that you care about, find some people that you want to associate with, serve well in that mission. And the great thing is, open source makes it easy for anyone. Right? It levels the playing field. Okay? Anybody can be a star based on what you bring in to an open source project. Don't settle, pick something great. Pick something you love. And make an impact. And I know you will. So, at ONOS, we're building a better network. We've got a vision of what we can do to improve it for the public good. We're doing that to make it open, agile, less expensive, all through open source. And we're building networks that enable innovation. And it's time to bring innovation back in the network. So I hope you join us on that mission. And I hope that you feel this way leaving today, that you had a very super ONOS day. So thank you for being here this late in the day. I really appreciate it.
Thank you, Bill. That was quite inspiring. I love the last photo, the first photo and the last photo. So has everyone voted? The network is down.
Do we need more inspiration?
How timely. How timely. So we can do a show of hands. So we had this really cool tool that showed live results. It's called voxvote.com. And it was fun to use. It just depended on a reliable connection, and unfortunately we don't have that. So I think we do have to. That was our plan B. Our plan B is a show of hands.
Right? Because it's all.
It's on. Sure. Just wonder how to use this file and use Sorry. Oh, I didn't know it was on the mic. I didn't know. Hopefully this works. Suspense. Oh, 81 votes. Okay, here we go. Oh, here we go. These are the final votes. We're in. 81 votes, and Team List SBI has won with 30.9% votes. Well done, well done. Okay, so and really, it was a close second is Team Snappy with 27.2%. And the third prize goes to Team Roll the Control. Great work, guys. Really good. Okay. So the prizes, as you know, first prize is $1,500 in Amazon vouchers. The second prize is $500 in Amazon vouchers, and the third prize are customized T-shirts. Ali has all the details, and that's why he has left the room. Seriously, he has left the room, but he had to catch his train. But you, team leaders, please follow up with Ali. He will give you all the details for the next step. So once again, thank you all the team hackathon teams. Thank you all for working very hard these past 2 days. And I want to thank everyone in the room who stayed till the very end. It was a fantastic first ONOS build, 2016, and we look forward to welcoming you all for the next edition, hopefully next year. Thank you very much.
Who's about business? What? I still have Alvin, yeah. Oh, I will send it out to everybody. So the picture will.